Hello everyone, welcome back to Edexcel Science channel. And now we are at question 20b. So the student moves a ladder to a new position so that the vertical distance from the top of the ladder to the ground is 2 meters. So this is 2 meters. The lines of actions of the three forces acting on the ladder intersect at the same point as shown. All right. So all the forces intersect at this point, right? Now, determine theta if the ladder is in the new position. So they're asking us that what is the value of theta at this position. So this question is mostly about trigonometry and doing geometry. That is all. It has almost nothing to do with physics. So this part, no, the length of the ladder is 2.07. So I can find out, okay, let me actually draw a triangle from this diagram so that it is much more clear. So let's say that this is the triangle, okay, and this is basically the ladder, right? So the ladder is 0.27 meters and the height is 2 meters, okay? Now we can find out the base of the triangle using Pythagoras theorem, right? Because this is perpendicular. So let's call it x. So x is equals root over 2.07 squared minus 2 squared. So that will leave us with 0.534 meters. Now, let's draw this triangle, right? This is also a triangle. And since this side and this side are parallel with each other, I can say that this is also 2 meters. Actually, no, 0.534 meters. Okay, but now we have to make an assumption, which is that um, it has been mentioned before that the ladder is actually uniform, meaning that the weight of the ladder must be acting through the center of the ladder, through the middle point. Because it is a uniform ladder, so the mass of the ladder is distributed uniformly. That means that since the line of action of the weight is through here, that means that this part is the perpendicular bisector. So this part and this part must be equal, and this is the perpendicular bisector since the line of action of the weight is through here. Okay, I hope that is clear. So if I want to find out this part, all I have to do is 0.534 divided by 2. And I know this part, I know this length, which is 2 meters. So I want to draw this triangle, okay? I want to draw this triangle so that I can find theta. So let me draw this triangle on the side again. So it should be something like this, right? So this is perpendicular, this is 2 meters, this is, okay, so this should be about 0.267 meters. So this is 0.267 meters, and this is my theta. So now I can use the trigonometric ratio of tangent theta to find out the value of the angle. So theta, all you have to do is just inverse. So you get the value of 7.6 degrees. So that is your answer. Okay, I hope that this one is clear. Now let's move on to question number C. The student climbs the ladder. Explain how the magnitude of the force Fw of the wall on the ladder changes as he climbs. You should consider the resultant moment about the bottom of the ladder. All right. So I have to consider the resultant moment from the bottom of the ladder. So let me actually remove all this because we do not need any of this for question number C. So in a sense, this has become my pivot. Okay. Now let's say that the child is over here. Let's assume that this circle is the child, which is classical physics. So the child has a weight which is acting downwards, right? Um, so let's assume that this is the weight of the child, W. Now, this force which is acting from the ground, the force that is applied from the ground, this force must be trying to balance this weight. Therefore, um, um, the force from the ground must be increasing. The weight is giving an anti-clockwise moment, so the force from the ground is trying to balance that, right? So the first point that I want to write down is that the resultant moment, right? The resultant moment must be zero. Okay, otherwise the ladder will be sliding. Now, because there is a weight of the child, right? Um, over here, because there is a weight of the child over here, the anti-clockwise moment of Fw must also be increasing. That is because if this force is increasing, right, that must be increasing as well. So I can say that the anti-clockwise moment is increasing. So um, if the anti-clockwise moment is increasing, right? If this anti-clockwise moment is increasing, that means this clockwise moment must be increasing because again, guys, the resultant moment, the resultant moment is zero. So this Fg is increasing to balance the weight, and this Fw is increasing because the total resultant moment in the system must be zero. So I have to write, therefore, the clockwise moment is also increasing, right? All right. So I can say that if the moment, right, the formula for moment is force times the distance d, over here, this moment must be Fw times d. So I can say that if this moment is increasing and the distance from the perpendicular point to the pivot is constant, that means that Fw must be increasing. Okay. Again, guys, if moment is increasing and this distance is constant, that means Fw must be increasing. So my final point is that Fw increases. Okay, so that is all for this paper. I hope that everything is clear. I was able to make everything easier for you guys. And if I'm helpful, please don't forget to like, subscribe, and comment and share the videos with your friends. I'll see you in the next video. Thank you.